demystifying APQP phases 1 through 4. Thank you.
Michael. So my name's Carl Evans. I work for Rolls-Royce. A bit of background to myself. I was one of the original writers of AS 9145. And then more recently, I've had the pleasure of leading the team on AS 13100 APQP and PPAP in terms of the requirements and the creation of the reference manuals we've generated. I've been involved in this subject in aerospace now since 2011. I've been actively involved with the deployment of PPAP through Rolls-Royce and our external supply chain, and more recent years the APQP aspect. During my career, I've been in many a functional role in quite a few different companies, varying in different industries. The point there for me, really, that's helped me get a real good appreciation in relation to application of APQP through cross-functional teams, and application of APQP and PPAP in different types of change. Transfers of works transfers, changes to manufacturing methods, introduction of new products. So that's been really helpful in terms of a lot of the work I've been involved with, but plus my peers which have been involved in this activity, these activities over the years, and the work we've been putting into the industry standards through the Aero Engine Supplier Quality Group. I'm going to talk now about APQP, focus on APQP predominantly, and then at the tail end make the connection back to PPAP. What I'm not going to do is be calling up line items of requirements in standards. I'm going to talk about it in a different way. I'm going to talk about it in a way to give you a concept from start to finish of what is APQP about, and then some of the insights in terms of helping make it work in your business, and some of the good practices we've got available via the reference material we have been creating in the Aero Engine Supplier Quality Groups. As a starting point, let's think about what's some of the key points that Ken said right at the beginning in connection to AS 13100 and specifically about APQP. So really the first thing is it heavily relates to the standard known as AS 9145 APQP. That was published in 2016. So the standard, the foundation standard for AS 13100 really has been around for quite a few years now in terms of the requirements document itself. So what's the role of AS 13100 in all this and requirements? Well, there are some additional requirements being called up around the subject of APQP and PPAP. Some of them have been shared with the earlier presentations, the use of submission level and related tables as an example. But when you actually look at the requirements in AS 13100, the bulk of them is pointing to AS 9145. In terms of actual requirements, there's very little that 13100 is asking for in terms of additions to 9145. So what's the role of 13100? And really it's been the bulk of what's the focus has been in terms of APQP and AS 13100 has been around thinking, publicising, putting in place best practices. So it's all about not only having a set of requirements, but having good practices that enable you to achieve those requirements. And the vehicles for that, there's a number of them available. There are the reference manuals, the RM documents have been mentioned a few times. There's one specific one on APQP and PPAP, but there's also a generation of other supporting reference manuals that back the supply chain in understanding best practices that are available. There is a network also of subject matter interest groups, and there is other vehicles such as community of practices, which you can find on LinkedIn as an example. So I'm going to spend time now really drawing attention to the best practices and giving you a view from start to finish of APQP. Specifically then for aerospace, so why APQP and PPAP for aerospace? It's the APQP, Advanced Product Quality Planning, is not something new. It's not something invented in aerospace. It originated in the 90s in automotive industry. You can find APQP in all sorts of sectors, wind turbine businesses. It's not something that is new in the world of industry, nor is it something that is not achievable in aerospace. What APQP is really focusing on is improving quality and reducing cost. So for our industry, aerospace, that's an important node, but also really what's important is when you've got higher levels of quality, that is synonymous with increased product safety. So there's a really important attribute that APQP brings around increased product safety. The diagram I'm showing you now on screen now, this is source information from the IAQG. It's quite it's a visual that's available for anyone to access. It's well talked about, and what it's doing is giving this concept of what is the actual total cost during a product development cycle. So on the left-hand side, it's mapping the costs against the development aspects, and then going into production, what are the costs? The first piece to point to is the purple line. And really what that's saying is in current state, there's a level of investment going on in terms of developing products and processes, and this isn't solely about a design of a product and implementing it. This is also about the manufacturing processes and the processes and supply chains that support those. But what it's mapping is that in a more traditional way, we don't put enough investment up front into the development of products and processes. But what we then do is, whilst in production, we develop those products and processes. And the result of that is costly. And the reason it's costly is because as you discover more and more around the performance of the process, the performance of the product, that can lead us to routes of escape management, the need to resolve problems, which potentially leads us down the route to requalifications and redesigns of the product and redesigns of the process. And that then provides an increased cost through the life of the product as we produce it. But also there's a significant amount of disruption, what happens within the business as a consequence of that. If we take a different view and follow the green line, and what this is now talking about is application of APQP and PPAP. And the first thing we draw your attention to is on the left-hand side is it is mapping an increased cost at the front end of the process. And it's about, because one of the key things about APQP is there is a level of upfront investment. And the reason there's that upfront investment taking place because it proactively focuses cross-functional teams on risk identification and mitigations. It's all about front end of the process, about capturing what the requirements are, applying good techniques such as DFX, understanding the risks in the product and the manufacturing processes and supply chains through FMEA. So what it does is it's promoting early on in the development cycle the use of robust, proven techniques to uncover what risks are there and put mitigations in place. And it does that through a cross-functional team outlook. The result of that, as you follow the green line over, is that at a faster rate you gain a maturity in terms of the product in its early life and early production of the product. It flatlines in terms of those costs, and the reason that's taking place is the investment upfront, identifying what is expected, the requirements, making sure we can produce the product, identifying risks through proactive actions through cross-functional teams. The outcome of that is a more rapid pace over the life of the product in terms of the maturity of the product itself and the manufacturability of it. The final piece of it is it provides a really solid foundation for ongoing change management. And when I say ongoing change management, the design of the product falls into that, as well as the actual process itself. So ongoing change management of the manufacturing process and things like moving facilities, works transfers. It gives a really strong foundation for any change going forwards. So APQP in aerospace offers considerable amount of benefits in terms of the development cycle of products and processes. So now I think about what is this in terms of its taking place, opposed to going through line items of the requirements in the standards. I want to talk about now the whole concept of going from start to finish of APQP, and therefore what the requirements are looking to achieve, and then give you practices that will help you on that journey. So let's view APQP in our industry as a flight, and we're going to talk about the flight path we're going. And when I say a flight path, the reason I make the relationship to that with APQP is, and at the moment the illustration you see on screen is within standard, what it does is it represents against time what's expected to have been achieved. Certain deliverables at certain points going left to right in a development cycle. So like a flight, we need a departure point and we need an arrival point. And that's what we're going to look at now when we talk about the application of APQP throughout the development cycle. So to keep this really simple and focus on what APQP is about when managing it through this flight path, I'm just going to pull out some key pieces of information. And these are, you can find these within the reference material, the RM 13145, to back this and give you more information about how to achieve these. So the very first one is, if we're on a flight path, we need to get ourselves off the ground. So the starting point for APQP is what's called the planning deliverables. That's the front end of the process. It's all about achieving a good understanding of what is expected, what are we going to change, and therefore what's the planning doing that. So see, the front end of the process is all about getting us off the ground in terms of the activities and work that needs to take place. So when we're off the ground, we're in flight. The next piece is what's called APQP and PPAP elements. So opposed to the planning deliverables, which are all about focusing us on getting off the ground and having to plan what is required well, the PPAP elements are all about the detail in terms of design, development, and validation activities. So these are the specifics that we do on the journey, on our flight. And really, they centre on two things. They centre on the phases of product design development and process design and development, and then eventually the validation phase. And they also centre on the plan that has been used, and the plan that has been used by the team, by the project, in executing what is expected in terms of APQP. So a simple way of sort of seeing this is, when we talk about a project plan in APQP, the currency you should be looking for is the elements. So have we got the elements planned for within the project plan? And therefore that is the specifics of what we have to do on our journey. The final piece to account for in our flight is what's known as the APQP and PPAP events. If we're departing from one destination point and arriving at another destination point, we want to have some in-flight checks as we progress. And that's really the role of what's known as the APQP and PPAP events. So it's really important at this point is that if you're holding in your mind three planned deliverables, APQP and PPAP elements, and then APQP and PPAP events. And these three pieces really help you achieve what is being asked at the detail level of the requirements within the industry standards. So let's take a little bit further. So if we're talking about these three areas of points of focus during a flight, what about the detail within them? So when you look at the reference material and these align to what the standards are saying, you will find that it accounts for 8 deliverables. So at the front end of the journey, there's 8 deliverables potentially that need to be focused on to get us off the ground. When we're working through the journey, we've got these checkpoints, which are events, and there's 12 of those. And then finally, when we're off the ground and we are designing, developing and validating product processes, there are 27 elements. So those are pretty key things to think about. Your reaction could be, does that mean then we have to account for 8 times 12 times 27? That feels like lots and lots of things. There's 2 points I'll draw on that. So, and to as a myth buster. Number one, think about APQPs going left to right on a cycle. You know, that left to right on a major program could be a number of years. It could be in a more short view in terms of managing change, say on a manufacturing process. It could be a far smaller window. But the focus is at points as you move across, you have a lens on some of these. So what it means is at any point in time, number one is all of these are not going to be the focal point. So the number is reduced. The second thing is, and this has been drawn up a number of times now, is these are actually configurable, and they're configurable based on various change situations. So another way of looking at it is the 8, the 12 and 27 can sit on a menu, and the menu is what drives which of these should be accounted for. And the way we express that is through different types of change situations. So in other words, a change situation, an example would be a brand new product design, or another change situation could be a transfer from one facility to another facility. They're all examples of change situations. What's really important to remember about APQP and in terms of what the standards are asking for is, and the guidance that supports it, is that for these 3 entities, deliverables, events and elements, there is a selection ability, and that is based on change situations. So let's help you a bit further in that thought. So in terms of change situations and these menus, on the right hand side, this is an example of one of the APQP and PPAP application matrices, which you will find in the RM 13145, the gold book image you see on screen now. How does it work? Well, you start with, what is the change situation I'm dealing with? Is it to do with a product design? Is it a new design? Is it a change? Is it a transfer, work transfer, moving from one facility A to facility B? Is it a change in the manufacturing method? Is it a new manufacturing method? Is it a change to the manufacturing method? And what these tables help you, I'll give you the indication of, is what to consider. In this context, the example showing the starting point is the product design. So is it a new design? is there going to be a change to the design? If there is, then that picks up on the first set of columns. If it's not, the next question is it a transfer? Is it a works transfer? And if it is, therefore there's an indicator and relationship with the related information on the matrices. And then finally, if it's not a new design or a change to the product design, and if it's not a transfer, then it must be a process change, a change to the manufacturing method, as an example. And you'll see on the tables that there's some variances there to give some understanding about the difference applying APQP to a new process versus a small change in the process, or a negligible change, or changes to specific tooling and stuff. So that's how these work. We start, APQP should be viewed as a flight path. That flight path takes account of three key things through the whole journey: the deliverables, the events, and the elements. And that's supported, the configuration, the detail around those are supported around these application matrices, which are based on the type of change you're dealing with. So let's take a little bit more of a look at this journey as we fly through. So we're starting here with the planning phase. Top left-hand corner gives you the indication of the flight path and the checks on way, and where the starting point really is something called kickoff, moving to PDR, the preliminary concept. That's our starting point for the flight to get us off the ground. What are we focusing on when we're talking about getting off the ground? That again can be simplified. That again to 44 key areas. There are some key inputs to account for. Based on those inputs, we want to capture requirements, and concurrently with that, we want to have a preliminary concept. And when I say preliminary concept, this could be of the product, but also the process, the manufacturing process, the supply chain. So what we're gaining is a view of what is required, plus what do we believe the changes, or we believe that what we're trying to achieve in terms of a concept. The final piece is a plan being created off the back of those. And that then becomes the output of the planning phase. And really what we want you to think about with the planning phase is any of the change situations I've described so far will benefit from good planning. As big, as complex as they are, or as simple as they are, those basic concepts of planning, of the planning phase, will benefit any type of change. Levels in the detail, and this is what you see on screen. We're not going to go through each one of these in detail, but just keep talking about the overall concept and giving you the feel of this flight we're on. The things to point to is when we talk about a set of inputs, the standards call up the ones you see on screen. The question really is, why wouldn't you want to account for what the customer needs are? Why wouldn't you want to understand what history and lessons learned you've had from changes previously? Why wouldn't you want to explore good practices through benchmarking, and so on and so on? So where the standards pointing to these inputs, they are good practices to be accounted for. Then through the actions and activities in the planning phase, we then pick up the requirements capture, the preliminary concept, and then eventually resulting in the creation of the plan itself. And when we say creation of the plan, that's the detail that is executed to design, to develop the product and the process, and then ultimately validate those. So in the area of requirements capture, the focus is on the product, but it's also about the project as well. Some key aspects that what are the milestones of the customer needs. They're things that should be accounted for. When we talk about the preliminary concept, we're talking about the product, but we are talking about the process as well, the manufacturing process, the supply chain. Those two come hand in hand. We have to have a concept of what we're going to make and how we're going to make it. And then the final piece, when we talk about plan piece, when we talk about the output of a plan, as in a physical description of what is going to take place when and who's accountable. But there's other important aspects that are accounted for around subjects such as statement of work. What commitments and expenditure should we be planning for? What resources should we be planning for? And these are all the makeup of what the standards are asking for. But in a simple view, this is a way of seeing how you achieve it. That's the planning phase. Now, to help the planning phase, again, back to the toolbox, the best practices we've got in the reference manual. I'm going to give you an example, of use of these now. So we've talked briefly about requirements capture. We're not going to go any further in that or the preliminary concept, but these are two key inputs to when you want to create the plan. The other key inputs is the statement of work and the preliminary sourcing plan. Preliminary sourcing plan is the view of how you're going to execute the product design and the manufacturing, the producing of that product in terms of resources and organisations who will be involved in that. They come into one big input, and it's back to the thinking of the menus now. So the starting point really is to ask, what is the change situation we're dealing with? Is it a transfer? Is it a method change? Is it a new product design? And then we utilise the matrices we've talked about to give a view on which events and elements should be accounted for. So we've now got an idea then of what we should be accounting for in the plan. There's another tool in the box of the best practices within the reference manuals, and that's something called the APQP and PPAP timing plan. And what that does is it maps against these events, and the events are used as a way of understanding the relationship with time and the elements. And what it does is give that guidance in terms of when to expect an element to start and finish. So between the matrices and this timing plan, what you get is a view of, firstly, what should I account for in terms of events and elements? And the second one is, when should I expect these to start and finish? So the final piece to create a plan would be, what are the activities that achieve those? What's the time of those and who owns it? In other words, the plan itself can then be created in whatever format is suitable to your business and asked for by your customer. And that is centered on the elements and the events that are applicable and guidance from the use of the timing plan in terms of when things should start and finish. When we talk about plan, the execution of APQP elements, what I want you to think about is that this is very much a team sport. The visuals you see now on screen is itemizing the 27 elements. What it's doing is proportioning them out into areas of phases. So you can see, for instance, the pink area is actually talking about the product design development phase, and within there's 7 elements that are focused on. When you start looking at what the detail is in these, you can then start uncovering, actually, there's quite a few different people get involved in this. APQP is not about one function. It's about a cross-functional team execution. So if I was to look at the pink area, that's orientated around design activities around the product itself. So DFX, design FMEA. That means that brings in the design engineer and validation engineers in that area. If I look in the green area, that's talking about process design development, the manufacturing method, the actual supply chain itself being developed. And again, so does that not bring manufacturing engineering into it, along with the purchasing in terms of the supply chain? And then when we look down the bottom part, which is the yellow area, which is the product and process validation, again, there's a set of elements here, and they're really centered on making parts and using data from those. To make parts, we need to have product ordered. So again, brings in purchasing. When we make physical parts within our internal facilities in the supply chain, there's operations involved. When we're examining the data that is produced, again we'll have expertise coming into that. So very much APQP is a cross-functional team effort. It's a team sport, and it involves a number of areas in the business. A really good practice is to take the APQP timing plan, the visual shown on screen now, take the list of those elements and do something simple, which is called map it against a RACI. If you're unsure what RACIs are, Google it. Just Google RACI as in RACI, and you'll find lots of information on them. Essentially what it's doing is making it really clear to the members of the team back in your businesses who's accountable for what. So who's accountable, who's responsible, and in times where who might I need to consult around the elements and inform about information. And what it does is give a really simple structure and a clarity around who owns what in regards to the team that would be managing the product and process design, development and validation activities. So let's help this a bit further now. So we've talked about the planning phase and gave you the concepts of that, and then focused on some of the tools that really help you create the plan. And there's a strong message around that, around the execution of the plan is through a cross-functional team. So let's have a look at what's going on then when we execute the plan. So top left-hand corner, we're back onto where are we on the flight. The pink area is all about going from what's known as PDR to CDR. So the product design development activities. In terms of the green area, the process design development, the flight path for that is from the PDR, but it touches a number of the PPAP events, production readiness review, first article, leading us to initial production approval. The centre and the efforts around there is cross-functional team working, and their focus is to design and develop the product. The details of this is these elements is what you see on screen now, and that's the breakdown of the set of elements. At the moment, what you'll see on screen is this is counting out 16, and if you remember what I've said, we talked about there's 27. So there's some which haven't been accounted for, which I'll cover in a moment. But the key thing around here to think about is through the planning phase, we've understood what the requirements are. We've got a concept of what we're trying to do in terms of the product and the process. We've created a plan, we formed a team, we're now executing that plan and working through all the good stuff that needs to take place to help develop and design the products and processes. At a point in time, we will be in a position to say, we need now to check this out and validate this. And that's the role of the validation phase. Again, on the left-hand side, top left-hand side, you'll see the flight path. And the flight path for the validation stage starts kicking in at something called production readiness review. And again, it's coming through the first article. It's then going through the PPAP approval to ultimately, for the project, get to the point of production launch. What's going on in this space? Well, it's focused on the validation. So again, when we talk about a plan, the plan would have activities built into it about supporting the validation elements. And what's going on in that space in terms of the validation elements are, there's a list of these now being shown on screen. To give you a feel, ultimately what's going on is we're making some parts using the production process, and then we're capturing information that will help us about quality. And when I say quality, that is the performance of the process. So an example of measuring quality or performance of a process is defects per unit measurements. But we also then capture statistical information on key product characteristics. We want to understand the capability of the process. We also want to understand that is the process meeting the design intent, which plays the role for first article. But there's also other things in there which respond to rate. So something called initial manufacturing performance studies, which essentially is measuring the process in terms of how long it's taken to make and what the yield rate is, and rubbing that up against the original assumptions for the process. By doing that, we get a clear indication of the process's ability to meet rate demand. The quote from Deming is on screen here, a really important message to think about in terms of validation. You know, without data, you're just another person with an opinion. With data, you have knowledge. So we've picked up a layer of detail around the deliverables and talk about the planning phase. We picked up a layer of detail and talked about the elements of APQP and PPAP and how they relate to the design, development, and validation activities. The other piece in this is to talk now about events and think about what are events, these checkpoints on the flight path. Well, the way you can see events is this. Firstly, they help with timing. Timing in terms of planning your activities and when they're expected to take place. With a view of what those are, they also help with synchronization of the supply chain, teams to teams, and members of the team. So what I mean by that is, with clarity on when we should achieve certain events, the supply chain is all working towards one goal, one point in time. Then various projects, depending on the size of the projects, you could have multiple teams involved. So it's also they're helping all the teams synchronize because they're all working towards a common goal. And then if you just see the team as a set of individuals, the cross-functional team, again, those individuals are working to a common goal. Ultimately, what are we trying to do on this flight path? We're trying to get to production launch, and we're trying to do it all together. So the events help very much in terms of timing and synchronization. They also act as approval decision points. So at points in time, we need to make a decision. Do we go forwards? Have we met and done what we expected to? Or do we need to stop and fix? So that's the other aspect to think about these. They provide us an understanding of timing and synchronization, but they're also health checkpoints as we go forwards, as we go through the flight, to ensure that we're confident that we should be continuing to go forward, or do we need to stop and fix? So what's some good practices to think about in terms of the subject of events? So you will find in the reference manual, the 13145, the Gold Book on APQP, you'll find that for every event, there is a pass criteria. There's some clarity being put down of what you should accept, what you should be considering when you get to these different events in terms of the approval decisions. But that's not the only thing you need to think about. Behaviours are really important around events. It's really important businesses and leadership and those involved really think about promoting the transparency of the results of these. What the information they're declaring should be really taken account of and valued. So that's what I mean by transparency. Understand where we're at particular points and value that information. And also, in relation to that, we should value leadership behaviours, the right behaviours around event management. So when we understand where we are at a point in time, we should stop and fix it if it's the right thing to do, or promote the fact that we're happy to go forwards. So this behaviours are really important to think about when we talk about events and using them in businesses. The other thing, though, is to account for the events within your project management processes. So your organisation should build these as part of the framework of your project management processes. But the other thing you should do is have a review structure in place. You know, how often and how frequently those are, that's going to be dependent on the project and the makeup of your organisation. But it's really important to have some level of review structure in place around these. And then the foundation for these, it's using something called RAPIDS. Now, the purpose of RAPID, and again, if you're not familiar what's meant by RAPID, Google rapid decision making. There's plenty of information that describes it, but very simplistically, the way I would describe RAPIDs is it makes it really clear who the decider is. And by having the clarity of who the decider is, then you can also make it really clear who should be providing recommendations, what should be performed, what are some of the inputs into that, and what agreements need to be taking place. Now, today isn't about going into the details what our RAPIDs are. It's really worth looking into these because it puts clarity around what is expected at these events and who really is the decider. And really an observation of aerospace, and it's probably not that unfamiliar for other industries, is perhaps we get very confused about who the decider is, and we have too much bureaucracy around processes around approval and involving too many people. And the reason that is, some of it, or one of the reasons I believe, is we just haven't made it clear who's recommending, who's deciding. And that's why the RAPID way of thinking is a really useful thing of mapping out the individual, what is for each of these events the right RAPID for your business. So I'm going to wrap up now and finish with this final point in terms of this journey. Everything I've spoken about so far has been APQP, APQP, APQP. That is quite deliberate, because if we think about maybe how our industry's been adopting APQP and PPAP, the conversations certainly we talk about in the group we work together in, is that when you talk to the external supply chain, the conversations are predominantly feel like they're around PPAP, not APQP. The real key point I want to leave you with and think about when you talk about APQP and PPAP, and the reason we've just majored on APQP is actually APQP delivers PPAP. And the reason for that is a number of things, and a number of thoughts I'll leave you with. So firstly, think about APQP. It's all about the activities that have to take place. It's your sat-nav in the journey. It's giving you that guidance. APQP and the activities that take place, they're built into the plan that's executed. The plan that's executed is with many members of cross-functional team. And we've talked about there's 27 potential elements that could be in that plan. So APQP is driving the activities at the right time with the right people involved to the right level of standards. So what's the role of PPAP? Well, PPAP is just evidence. If we describe APQP as the sat-nav, think of PPAP as the traffic lights. At a point in time, a certain amount of evidence is provided to somebody independent of the team that is involved with APQP. And he or she is making a judgment about how well things have been satisfied in terms of elements. What you see on screen is the listing of the numbers of the 27 elements. The light blue ones are the indicators which say these are the elements of APQP and this is where we're looking for evidence. So what we're not doing when we talk about PPAP is accounting for all these 27 elements. We're accounting for some of them. And PPAP is looking for the evidence of compliance. And that's the link between APQP and PPAP. In other words, if you focus your efforts and work PPAP, APQP process, you will deliver PPAP as an outcome. If you focus on PPAP solely, then you're going to struggle to actually achieve the requirements, because if you're not investing the time in APQP and the activities that take place, you're not necessarily going to hit the standards. On that note, I'm going to pass over